Gradient boosting is an ensemble method. It gives a prediction model in the form of an ensemble of weak prediction models. You can use this technique for the regression and classification tasks. So, what is XGBoost? Let's discuss XGBoost. XGBoost is short for extreme gradient boosting. You can use XGBoost to implement gradient boosting. It provides a parallel tree boosting that solves many data science problems in a fast and accurate way. Scikit-learn has another version of gradient boosting, but XGBoost has some technical advantages. To install XGBoost, you can use pip install XGBoost command. If your target variable has categorical values like yes, no, or spam, not spam, this problem is now a classification problem. In this video, I am gonna show how to solve a classification problem with XGBoost. To do this, I am gonna use the adult dataset. Let's load this dataset with pandas. First, let me import pandas. Import pandas as pd. Let's load the dataset with the read CSV method in pandas. df equals pd.read CSV. Let me write the name of the dataset. Adult data. To read without the header, I am gonna use the header parameter. Header none. Cool! The dataset was loaded. Note that you can find the link to the dataset and notebook in the description below. Let's look at the first 5 rows of the dataset. df.heat. Here you go. As you can see, the column names are missing. Let's add the column names to the dataset. To do this, here I am gonna pass the names that I prepared before. You can access these names from the website of the dataset. Let's look at the first rows of the dataset again. df.heat. Here you go. Let's move on and take a look at the information of the dataset with the info method. df.info. With this method, you can see missing data, the column types, and the number of rows and columns. The dataset has 32,561 rows and 15 columns. Note that since all columns have the same number of non-null rows, we can say that there are no missing data. Here the education num column is a numerical conversion of education. As information is the name, we can delete the education column. To do this, I am gonna use the drop method. df equals df.drop. Let me select the education columns. Let me type square brackets. After that, I am gonna add education. To drop on the column, let me set axis equal 1. Beautiful. Note that the machine learning algorithms like to work with numerical values. Let's convert non-numerical columns into numerical columns with the getDummies method in pandas. df equals pd.getDummies df. After that, let's look at the first rows of the dataset. df.heat. Here you go. The getDummies method creates many new columns. Here, 1 indicates presence and 0 indicates absence. Cool! All columns in the dataset are numerical with no missing data. Now, let's create our target and feature variables. The target variable I want to get is the income column. The income column is whether or not someone makes 50 key. After implementing the getDummies, this column was divided into 2 columns. Income less than 50 key and income greater than 50 key. To see this, let's take a look at the names of columns. df.columns. Here you go. To specify the target variable, let's delete the income less than 50 key column. df equals df.drop. Let me set this column. After that, let me set axis equal 1. Cool. After that, let's create the feature variable with the ilog method. X equals df.ilog square brackets. I'm gonna select all columns except last column, colon, comma, colon, -1. Now, I'm gonna create the target variable. To do this, I'm gonna only select the last column. Y equals df.ilog colon, comma, -1. Here you go. So, we created the target and feature variables. What I'm gonna perform in the last step of data preprocessing is to split the dataset into training and validation set. The model is built with a training set, the hyperparameters are tuned with a validation set, and the model is evaluated with a test set. To split the dataset, I'm gonna use the train test split function. First, let's import this function from sklearn dot model selection import train test split. Now let's split the dataset into the training and test sets using this function x train full x test y train full y test equals train test split x y random state 0. Now I am gonna split the training full sets into the training and validation set. X train, X val, Y train, Y val equals train test split X train full, Y train full, random state 0. Beautiful! Our datasets are ready for building the model. Let's move on and build an XGBoost model. The problem we want to solve is classification. Before training the model, let's import the XGBoost classifier. From XGBoost import XGB classifier. Let's create an object from this class. XGB CLF equals XGB classifier. The XGB classifier class has many tunable parameters, but it has a few parameters that can dramatic accuracy and training speed. The first parameter I want to handle is an estimators. An estimator determines the size of the forest to be trained, while too low a value causes underfitting and too high a value causes overfitting. Typical values range from 100 to 1000. Let me set 500. And estimators equal 500. You can use learning rate to limit the influence of individual trees. In general, a small learning rate and a larger number of estimators will yield more accurate XGBoost models, but the model takes more time to train. Let's set this parameter to 0.05. Learning rate equals 0.05. I don't want to use a label encoder. Let me set use label encoder equal false. I'm gonna use the values of -1 to use all cores on the machine, and jobs equals -1. Cool! We created an object from XGB classifier class. Now let's build the model using the training set. XGB CLF dot fit X train Y train. The parameter I am gonna specify now is the early stopping round parameter. This parameter helps us to find the ideal value of the n estimated parameter. The model will train until the validation score stops improving. Let me set 5 for this parameter. Early stopping rounds equal 5. You need to use an eval metric for early stopping. Eval metric equals log loss. To evaluate the model, let's set the eval set parameter. Eval set equals square brackets xval yval. To see the evaluate metric, you can use the verbose parameter, but I don't want this. To do this, let me set verbose equal false. Awesome! The model was built. Let's take a look at the performance of the model using the test set. Since our problem is classification, I am going to use the accuracy metric. First, let me import the accuracy score function from sklearn metrics import accuracy score. Let's predict the test set using this function. Pred test xgb clf dot predict x test. Let's see the accuracy of the model on the test set. Accuracy score pred test y test. As you can see, the model has an accuracy score of 87% on the test set. Let's see the accuracy of the model on the training set. let me copy this code, paste it here, and let me set train and train full, train full. Here you go. As you can see, the model has an accuracy score of 88% on the train set. Now, let's compare the XGB classifier model with the logistic regression model. Logistic regression is one of the most used classification algorithms. To build a logistic regression model, I am gonna use the scikit-learn library. First, let me import logistic regression class from sklearn linear model import logistic regression. After that, I am gonna create an object from this class lr equals logistic regression. I am gonna use the default values, but I am gonna only set the max iter parameter. The max iter parameter is used for solvers. Max iter equals 1000. To train the model, I am gonna use the cross validation technique. This technique is used the key fold approach. In this approach, you split the data into key fold. The model is built with key minus 1 fold and the model is evaluated with the remaining fold. First, let me import the cross-val score function from sklearn model selection import cross-val score. Next, let's build the model with this function scores equals cross-val score. First, let me write the model lr. Next, I am gonna type the variables x, y. Let me set the CV parameter CV equals 10. Cool, the 10 scores were found with 10 folds. Let's calculate the mean of these values. To do this, I'm gonna use numpy. Let me import numpy. Import numpy as np. Let's use the mean method. Scores dot mean. Here you go. As you can see, XGB score higher than the score of the logistic regression. That's it. In this video, I talk about classification analysis with the XGB classifier technique. I showed how to build an XGB classifier model and I compared the XGBoost model with the logistic regression model. As a result, it turns out that the performance of the XGBoost model is better than the performance of the logistic regression model. Thanks for watching. I hope you enjoyed. You can find the link to the dataset and notebook in the description below. Don't forget to subscribe to my channel, like the video and leave a comment. See you in the next video. Bye for now.